right. What I did, I'm trying to put up the syntax for the concept of select statement. You write up a select name, put up a from table, and then we could add a where clause. We've not done that before now. Select column name, now which could be from our customer table. We have a customer name, we have city. You can specify what you want. We also have the age. Now, from what table? Customer table. Then you could add a where clause, and that's the example I try to put up here. Select name,
Yeah.
city, from customers, and then I added a
Mm.
where clause where the city in this instance is Suleja. And if I run this, which I did, I have this. I had to add one new row, one new record, so I have two persons from Suleja in case you didn't update your own. You just update that slightly. So you still getting the error? Are you still having an error?
Um, 1 second. I'm just trying to show record now. Do I have to run that show record alone?
Okay,
Show table.
show table. What do you want to do? I didn't get that.
Trying to show the result, the customer table.
So run a select statement. Select all.
Yeah, yeah, that's what I'm doing. So I've said select name, city,
Can you
yeah,
share your
from.
screen, please?
Can you see my screen?
Yeah, I'm seeing your screen.
So this is what I'm trying to run now.
Select
I can't see.
name, city, from customer, where city equals. That's your city. Read the error.
Yeah, where city equals. Shouldn't there be a gap?
Hold on. Where is the red indicator showing from? The first place you're seeing
Hmm?
the error, where is it?
Can't even see.
Now see what I mean. Line 53. That's where the error is indicating. What do you think is happening there? Good. Beautiful.
Oh, that didn't happen before. So why didn't you pick that one up before?
Before it showed it. That's why you're having that error now.
Yeah, but okay. Where's city name? Why is city name?
Select name, city
City.
from customer areas. Wow, I lost you again.
Can you see that?
Yeah, it's not you're not presenting yet.
Can you see the screen?
Yes, I am seeing that. All right, let's look through it together. Select name, city, from customer. The what's it called? Your table name, is it customer or customers? right?
Yeah.
All right. One of them being some. Okay, that's the concept. That's the syntax. That's how it is done. That's how you um. So at the moment, what are you able to do? Can you create a database? How do you do that? The syntax, if you're using the SQL, you want to write query for it. It's create database, then the database name.
Yeah.
Good. If you're if you're using the GUI for Workbench, you use the schema icon,
Hmm.
top left, to create a new schema, name your schema, and that's it. And then having done that, if you want to, not if you want to, you should want to um, work on the database you just created. So the next thing you most likely, I should be sharing my screen to do this. Let me share so the
Okay.
explanation sounds clear enough. As much as possible, I'm trying to avoid a work overload on you. I know we've covered quite a lot this morning or right now. I don't want to push further except you want me to add something, some more things in the next 10 minutes. Well, I just want to do a recap. The way I structured it in the with the space, we'll complete the class within the specified 4 weeks duration. At least we've been able to do two things today. We did all we did, and you had a classwork concluded, and I'm trying to do a recap. So I said to create a database using the code, you simply would have written create database, then DB name. That's just a syntax for you. Clear?
Yeah. Yep.
All right. And in this instance, this is our database name. So uh, another way to do that, if you're working on MySQL Workbench, there are other tools to do this, not necessarily Workbench alone. But we're using Workbench. I think I love Workbench. It's beautiful. It gives you sweet environment, helps you preserve your written queries, and you have a good view of everything you need. So one of the ways again is using the GUI. We could create new schema by using this cylinder icon. Click on it and then name your schema and apply. That will be saved. I'm not doing that again now. But let's assume I want to do that. We'll say new DB and then apply. That will be saved. I'm not doing that now. Don't save. So having done that, the next thing you want to do is work inside the database you just created. To do that, we could use then the DB name. In this instance, my DB name we're working on is this. So that's the way to apply everything we're doing on that DB. One way using the code, using the GUI, which I still like using for this case, for this course. I could just on right click and that same DB created. If I didn't see that DB created on the left pane here, where we have our schemas, use your refresh icon. Use your refresh icon. It should show up. Everything you did should be updated. And then
Yep.
right click here and then set default schema. That means, what this means is that everything I'm doing henceforth, every code I'm executing would be applied to that schema, that DB. That's what it means. And I tried defining what a DB is. In a layman's term, I said a DB is likened to a library, a physical library. And in definition, where it's a collection of data, a well-ordered collection of data that particularly does three things or four things. It gives you the ability to easily sort your data, to easily retrieve records from your data, easily modify records by creating new records and easily delete. So the idea easily, it's key because if your data is not well arranged, you're not working on a database, probably in a warehouse, a storehouse, where items are packed or lumped one on the other. If you ask someone to get a particular item from that warehouse, it's not easy to do that, depending on how much item you have in that warehouse. But when it's well sorted, arranged, more like a database, Now we could easily retrieve items from the DB. That's why we say, well orderly, uniformly organized set of data. Now, the warehouse itself is more, or the library itself is just the database. Data is not stored directly into the warehouse. There's something that holds your data. It's called tables in database. And I liken the tables to be like your shelf in your physical library where the books are kept. Your shelf is like your table where the books are kept. So the tables hold the data. So when we create a table, we define the table, define what the table, every table has rows and columns. Now each row also called, each column also called a field. So you could hear column, field, the same thing. A field, most times I use the word field. A field, a column, same thing. Each column is named and each column is defined. You define what data type it should contain, the character length of the data type that should be entered into it. That's what we did here when we say create table customers. We define the fields, the column names. The first field we named ID, and this ID is usually your primary key. Usually, not must. You could name your primary key as something else, but as a convention, it's ideal that you attribute or give or create an ID to your table. Why? Identity, that's the word ID. And assign your ID your primary key. The main reason is that in most cases, if not all the cases, the ID is not humanly manipulated in the sense that the system, the database engine, automatically creates the ID for you. So the chance of making a mistake in creating that is almost a zero. I can guarantee it's a zero. Is a zero in the sense that if I, okay, let me do a select statement so we see from what we had earlier. We had, you can see this clearly. We have, you see my screen, right?
Yeah.
We have John Doe with ID 1, Chooks Edwin with ID 2, Ben Ola 3, and like that. We didn't insert these IDs. We just inserted records of name, city, and age, as we have here, name, city, age. Now the system is automatically creating these IDs, and there's no time. Now, if I rerun this, and I think I'm going to do that, but please don't do that with me. If I rerun this, let me do just that. We'll see this record replicated. Don't do that with me. I'm just going to do that. I rerun this. Now, having run this, let me do a select statement again and show you something. Wow, I got that wrong. It didn't run for reasons best known to it. Why did it not run? I didn't have a success. Why? This is what I want to run. Okay, beautiful. And my select statement should now run. Beautiful. This is what I want to show you. If you can see my screen, and I have records duplicated. I have Chooks Edwin, I have Chooks Edwin. Abdul Danjuma, Abdul Danjuma, right?
Yep.
Now this is not wrong in practical terms. It's not wrong because you don't have a monopoly of names. You alone don't bear your name. Certain persons could have. Sometimes I think in my secondary school, JSU particularly, we're three in my class bearing my name, three. So it happens. So this could be right. Practically, you could see something. However, no two records can have same ID. The first Chooks has an ID of 2. Second Chooks has an ID of 7. First Ben has an ID of 3. Second Ben has an ID of 8. What this means is that each of these records is uniquely identified by its ID. So if I say, call me the staff with, or the customer with ID 2, Chooks from wherever and with its own record knows you're referring to him, or the database knows you're referring to this person. For example, let me run a query to select that guy right away. If I say, if I run a query to say select all from customers where Select all from customers where name equals choose Edwin. We're bound to see something not okay. We have two, right?
Yep.
However, if I say where ID equals 2, there's never a time I'll have more than one record.
Yeah.
So IDs are unique, and that's the only reason, or one of the reasons you need to name use your primary key for your IDs, because the system provides these values itself. The chance of making an error is almost zero, and then it's auto incremental in the sense that it increases itself. So there's no time you have two persons having ID of 2. So records are best called by the IDs. If you do programming, by programming I mean software development and the likes, you see greater benefits of this ID. So that's why we always advise that each record has a unique identifier. For a good data set, you would have something like this, depending on what you're working on. For a very good data set, you most likely will have this. Okay, having explained that, I said that just to say that our primary key is a unique identifier to every record in a database. Primary key is the unique identifier to every record in your DB. The unique identifier to this set of records I have here, 1 is John Doe, 6 is Damian Adeni, and like that. And there will never be a time where two persons have 6. So that's about the primary key and defining our fields. City, Parker. Now next class, I'll start by treating data types. That's what we do. Just it's going to be a very brief one. Data types before we talk about every other thing. Talk about data types. Please remind me, should I forget that?
Cool.
All right.
Yep.
And then we talked about insert statements. Insert statements. The insert statement is used to insert records into tables, as the word implies. Insert, to put in records into table. And when you insert into the table name, and then you have the fields defined, the fields in the table defined. Now, you observe that we did not call our ID field here. We did not do that because we didn't need to do that. And we didn't need to do that because we told the database to always auto-generate this field. So we need not do that. We're just calling or inserting every other record. And as we do that, this ID is auto-generated. So insert into customers the name, the city, the age. These three fields we want to insert records. We started by inserting a single record. When we did that, we had just something like this. Yes, this is what we had. So we inserted single record. And then choose Edwin from the city of Onitsha. Age is this. And then we also went ahead to do multiple insertion. By that, we separate each enclosed bracket with a comma, with a comma, with a comma, until the last one we terminate with a semicolon as usual. So we insert in the customers every same thing. I just copied and replicated this. And having inserted, the next thing you do is write a select statement to see what you've done. I selected all. The star here represents all from our table name, in this instance, customer. And when we did that, if I run that, I get just this. And then we also went ahead to select specific records. Now, not selecting all, I just want to see the name and the city from the same customer. Notice, select all from customer. This select and the from table name, they are constant from customer and the select. So the difference is the all. Start meaning get me everything about the table. The next thing, the alternative of it is that I'm defining what fields I want to see. Just with time, you get your hands dirty with that. So I'm defining what fields I want to see. The next thing we did, when I did that, let me run this. When we did that, we had just, sorry, Yeah, we selected the name and the city. The next thing was that we wanted to limit the number of records we are seeing. At this moment, I'm seeing uh, how many records here? About quite a lot. The IDs are not shown here, as you can see. So I want to limit the record output to just 3. So I use the limit statement, the same select all, but I'm limiting now. Or you can do the limit thing here to still run this same query. You can do the limit. It could be lowercase, not necessarily uppercase. Limit 4. Still can do that here, and then see that. So any select statement you run, you can run your limit. You can limit the number of records output you see. Exactly.
Yep.
All right. So that was that. We did a class of you did that and you did good. Thank you for doing that. Um, the last thing I talked about was that I added a where clause to our select statement, trying to give you a syntax of how a select statement works. Select column name from table name, and you could add a where clause. This is optional. What we've been doing earlier, we didn't put a where clause. Now we added a where clause now to see how many persons are from a certain city. And when we do that, it works, gives us all of the persons from the same city. We could also filter the where clause to get persons of same age or same name, like that. Thank
Okay.
you.
Cool. Thank you so much.
You're welcome.
Yeah.
You're welcome. So